Hello everyone, welcome to Civil Engineering and Stuff. And in today's video, we are going to discuss another method of traffic signal timing design, and that is called as the approximation method. So, if we talk about the design of traffic signal timing, if we talk about the design of traffic signal timing, we have discussed in the previous video regarding the basics of the design of traffic signal timing. There we have discussed about the two-phase and four-phase traffic signal system and what are the parameters that are taken into account while deciding for the red time, the amber time, as well as the green time of the traffic signal. Right? In terms of design of traffic signal timing, we have discussed one method that is called as the trial cycle method. In the previous videos, we have discussed about the trial cycle method for the design of signal timing. Right? You can watch these two separate videos for more information. In today's lecture, we are going to discuss about the approximation method for the design of traffic signal timing. Right? So, in trial cycle method, we discussed that cycle time is assumed, and considering that we decide the eventual total cycle time for the traffic signal. In this method, in your approximation method, what we do is we include the pedestrian crossing time. We include the pedestrian crossing time, right? And based upon this, like the green time, the time required for the pedestrians to cross the intersection, we consider the pedestrian crossing time. Let us discuss in detail. So basically, what happens is that again we take this intersection. We have discussed about this intersection over and over again in our discussion in the previous video, right? So this is road A, this is road B, and of course the vehicles are coming from road A as well as vehicles are coming from road B. So in approximation method, as I have just said, that we consider the pedestrian crossing time. So the time required for a pedestrian to cross this width of the road safely is considered, right? So pedestrian who is crossing this road section safely, that is taken into consideration as the green time for pedestrian, and taking this green time as our reference, we design the traffic signal timing. All right. So let us discuss the design steps and and then we'll do a numerical for a better understanding. All right. So like I said, in approximation method, what we consider the pedestrian time required for the pedestrian to cross the road section. All right. Let me just discuss few basic details also before I move ahead. Okay. So this is the road intersection. This is the road intersection. This is road A. This is road B. All right. So as the vehicles will be going from A as well as B in their respective green time. So let us say that vehicles are moving in road A, right? If the vehicles are moving in road A, will the pedestrian movement will be allowed? If it is green at A for vehicles, if it is green at A, will the pedestrian movement in the road will allowed? The answer is no, right? When the vehicles are moving in road A, the movement of pedestrians in road A will not be allowed. Clear? Likewise, if the movement of pedestrians is allowed in road B, if the movement of pedestrians is allowed in road B, will the movement of vehicles will be allowed in road B? I'll again repeat. If we have allowed the pedestrian to cross this road width, right? We have allowed the pedestrian to cross this road width. Will vehicle be moving in this road section, in road B? The answer is no, right? For the safety of the pedestrians, as and when the pedestrians are crossing the road B, we will not allow the movement of pedestrians in road B. So, is it safe to say that for the time period when we have green time for the pedestrians in road B, when we have green time for the pedestrian in road B, this green time will be equal to the red time for the vehicles at road B. Yeah, when we have green time for the pedestrians in road B, at the same time we will have red traffic signal for the vehicles in road B. Clear? The same will go for road A also. Right? I hope this concept is clear because this is what we are going to use in the upcoming design step. Right? If this concept is not clear, do let me know. I'll create a dedicated video regarding this concept in detail. Okay? In terms of phase diagram. Okay. So, coming to the design step, the first step is the green time, the minimum green time required for the pedestrian to cross the road width. The minimum green time required for the pedestrian to cross this road width. The formula is GPA is equals to 7 plus WA divided by 1.2, where WA is the width of the road A. WA is the width of the road A. Likewise, this WB, if I say, will be the width of the road B. Right? So the green time for the pedestrians for the road A will be 7 plus WA, that is width of road A divided by 1.2. Alright. Now this 7 is what we call as the initial walk period. 7 is what we call as the initial walk period. Right? Initial walk period is like this is in seconds, 7 seconds. Like this is a safety time that we include, right? Like if a pedestrian is waiting for the light to turn green for it, right? We have pedestrian traffic signals, no? We have pedestrian traffic signal something like this, right? And this pedestrian is waiting for the signal to turn green. So it is assumed that 7 seconds is taken for the initial walking. What does this mean is that if this is like here, if here is we have the traffic signal, right? And our pedestrian is, let's say, somewhere here. Our pedestrian is, let's say, somewhere here, and now it is green for the pedestrian. So at least 7 seconds will be taken by the pedestrian to reach to this footpath, right, and then cross the intersection, like to reach here. Like this is the initial walk period, right? This is the initial walk period, or it will start from here and then it will start to walk. This is just like a safety time period that is given, right? WA is the width of road A, and 1.2 is the time for pedestrian to cross the road. This 1.2 meter per second is the what we call as the pace of pedestrian, right? The pedestrian is moving at a pace of 1.2 meter per second. This is in meter per second. This is the pace of pedestrian. Clear? So green time for the pedestrian at A is equal to 7 plus WA divided by 1.2. In the similar fashion, green time for the pedestrian at road B will be equal to 7 plus width of road B divided by 1.2. Right? Green time for pedestrian at road B will be 7 plus WB divided by 1.2. Alright. So this is the step number 1. We have to find out the green time required for pedestrian signal. Right. Then the second step is to find out the minimum red time for two routes. Right. So this green time is in terms of pedestrians. Now taking this green time as our base, we are going to calculate for the vehicle. Alright. So just now we have discussed for the vehicles for road A, the red light at A, if we take the pedestrian green time, the red light at A will be equal to what? Will be equal to GPA or GPB? Just think about it. Will be equal to GPA or GPB? It will be equal to GPA. Right? That is green time for pedestrian at A. Right? It makes sense, no? Like when the pedestrians are moving at road A, of course, the vehicle should not move at road A. So this will be red time at road A. In this similar fashion, the red time for road B will be equal to what? It will be equal to GPB. Red time for the vehicles at road B will be equal to green time for pedestrians at road B. The pedestrians are crossing the road B, so we do not want the vehicles to move, right? So it is the red light or red time for vehicles at road B. Clear? So in step 2, we have find out the red time. In step 2, we have find out the minimum red time on the two roads, taking the green time for the pedestrians as our point of reference. Now, taking these red times, we are going to find out the minimum green time for the vehicles on the two roads. Taking this red time for the vehicles, we are going to find out the minimum green time for the vehicles. In step 1, the green time was for the pedestrians. In step 3, the green time is for the vehicles. So, to find out the green time, we have the red time, right? And we know, we have discussed over and over again, the red time at A will be equal to green time at B plus amber time at B, right? I hope you are well versed with this relation now, right? If not, we have discussed about this in the when we are discussing about the basics, right? So red time at A will be equal to green time at B plus amber time at B. So through this we can find out the green time for B, which is equal to red time at A minus amber time at B. In the similar fashion, red time at B will be equal to green time at A plus amber time at A. Correct? Which is green time at A is equal to red time at B minus amber time at A. Alright. So through this we have found out the minimum green time for each road for the vehicle. Now this green time that we are talking about in step number 3, this green time we have obtained with respect to considering the green time for the pedestrians at the respective road section, right? This green time for the vehicle is obtained by considering the green time for the pedestrian, right? So now taking any of these green time, or to be precise, taking any whoever is the highest green time, we are going to find out the green time for the road section with respect to the traffic volume that is moving in the road section. I'll just repeat again. This is the road intersection. This green time we have obtained by taking into consideration the green time for the pedestrians at the respective road, right? So these green time has taken into consideration the pedestrian parameter, right? Now we want how much traffic volume based upon the quantity of traffic volume based upon the number of vehicles approaching per unit time. We want to find out the green time taking the traffic volume as our reference, right? So for that we refer to step number 4, and step number 4 says that we have to consider any one of the green time GA or GB that is found in the step number 3. G and GB that is found in the step number 3. We have to consider any one green time as calculated above, and another green time is found using the traffic volume on the two roads. What does this mean? That out of the green time that we have found, right, whoever is the highest value, we are going to take that value, and using the relation is using the relation GA by GB is equal to NA by NB, where NA and NB is the traffic volume at respective road. Traffic volume at respective road, right? Using this relation and taking any one green time that is found in the above value, which value will take? The higher one. Which value will take? The higher one. If GA is higher than GB, we are going to take GA. If GB is higher than GA, then we are going to take GB. Using this value, we are going to find out the green time for another road, right? So let's say if GB found in step 3 is considered, GB found in step 3 is considered, then GA will be equal to NA by NB into GB, right? GA will be equal to NA by NB into GB, right? So through this, the total cycle time, let me just for the sake of understanding, let me call it as GA dash, right? So we will have the total cycle time GA dash plus amber time at A plus GB plus amber time at B, right? So this is the total cycle time. Clear? Now let me discuss the same with the help of phase diagram, right? We have, let me draw for road A and road B, right? Road A and road B. This is for traffic. This is for traffic as road A comma road B. The another phase diagram that I am going to draw will be for pedestrian. This is road A, this is road B, and this is for pedestrian. Pedestrians at A and at B respectively. Alright. So if I say first of all, I have green time at road A, I have green time at road A, as well as I have amber time at road A, right? If I say I have green time at road A, amber time at road A, this time will be equal to, for the traffic at road B, this time will be equal to red at road B. So we have discussed about this in the previous lectures. Actually, you can refer those lectures if you have any doubt regarding this phase diagram, how to draw that, or if you have any doubt, you can always ask in the comment section. Right? When there is green at A, that is traffic is moving at green and amber. So of course it will be red at road B. Likewise, when it is red at road A, when it is red at road A, this means the traffic is now not moving in road A. So of course at that time the traffic will be moving in road B. So we will have green in road B plus amber in road B, right? Amber in road B. The purpose of amber is that all the moving vehicles, when it was green in road B, and green will be followed by amber, because and the moving vehicle, when they see, either they stop or they cross the intersection, right? We discussed about this, so I won't go in detail, right? So when it is red at A, it will be equal to green at road B, amber at road B. When the vehicles are not moving in road A, vehicles will be moving in road B. This is for traffic. Clear? This is for traffic. This I will just, for better marking, I will do it. Right. Now this is for traffic. Now let us draw for pedestrians. Right. So if you observe, we have red at road A for traffic, for cars. If you observe, we have this as red at A. So of course, when we have the red at road A, so of course we will have green at road A for the pedestrian. When we have red at A for the vehicles, we will have green at road A for the pedestrian. Right? We will have GPA. Right? We will have GPA, green time. Right? And during this time frame, when we have green and amber, that is when the vehicles are moving in road A, we will have what we call as the do not walk interval at road A. DWA is do not walk period. For whom? For pedestrians. Right? So when the vehicles are moving in road A, so this will be the do not walk period for the pedestrians in road A. Right? I hope it is clear to you all. Now let's go for road B. Now if you see at this time frame RB, at this time frame when it is red for the traffic at road B, what we can say, at this time frame when the vehicles are not allowed to move at this time, we can say the pedestrians are allowed to move in road B. And when the vehicles are allowed to move in road B, the pedestrians are not allowed to move in road B. So we will have do not walk period. Right? So we will have do not walk period. Right? We will have do not walk period at road B. Right? So if I say what is the do not walk period for pedestrians, if I say step number 6, if I say what is the do not walk period for the pedestrians at road A. If you look into the diagram for road A, the do not walk period, this do not walk period will be equal to this do not work period will be equal to the green time and amber time for the traffic at road A, right? So this do not work period at road A will, will be equal to this do not work period will be equal to green at A plus amber at A, green at A plus amber at A, right? In this similar fashion, do not work period for B, do not work period for B will be equal to green at B plus amber at B, green at B plus amber at B, right? Clear? Now what, I hope this is clear to you. Step number 6 is clear to you. Now the seventh parameter is the clearance interval. The clearance interval, right? That is the whole of the passengers crosses the width of the road. Whole of the passengers crosses the respective width of the road. Alright. So this clearance interval for road A, we have seen the pedestrians move with a speed of 1.2 meters per second. This is clearance interval is nothing but the time. Time is equal to distance upon speed. Distance that they have to cover is the width of the road at A. Likewise, clearance interval for road B will be equal to width of the road B divided by 1.2. Right? So this clearance interval is nothing but a kind of a amber time for respective road. I'll again repeat. Clearance interval you can assume as an amber time for the pedestrian, right? And WA and WB we have discussed at the starting of the video. This is the WA if this is road A, and this is WB if this is road B. The pedestrians move with a speed of 1.2 meters per second, and we want whole of the pedestrians to cross this, right? So the clearance interval will be equal to distance upon speed, WA divided by 1.2 meters per second, which you can assume as an amber time for the pedestrian. So if I want to show in this phase diagram, so this will be equal to, I'll use a different color here just for the, since it is clearance interval, right? So it will be what? Clearance interval for road A, nothing but a kind of a amber time. Alright, clearance interval for road A, and in the same manner we have clearance interval for road B, just like amber time for the pedestrian, right? So this is kind of a clearance interval time for the pedestrian. Then if I say what is the walk period, what is the walk period on the two roads? So walking period for the pedestrians at road A will be read at A minus clearance interval at road A. If you look here, this is the walk period. Walk period. This is the walk period. And this walk period for respective roads. This walk period for respective road we can find out as the red time minus the clearance interval, right? This will be equal to clearance interval in road B will be equal to wait time at B minus clearance interval at road B. Alright, just focus on this on the phase diagram. Just look into it. If you have any doubt, you can always ask in the comment section. Alright, no doubt in that. Right? I'll just, for your sake of understanding, I will again repeat what we have discussed through the phase diagram. Okay. So quickly speaking, when we have this phase diagram is for traffic, this phase diagram is for pedestrians. When we have vehicles moving in road A, so of course we will have red at road B. In the similar fashion, when the vehicles are moving in road B, we will have red time in road A. This much is clear. So this is in terms of traffic. If we talk about in terms of pedestrians, when the vehicles are moving in road A, pedestrians should not move in road A. When the vehicles are not moving in road A, pedestrians are allowed to move in road A. So just like amber time for traffic, we also have clearance interval for pedestrians. So this green time will be equal to walk period plus clearance interval, right? And clearance interval is the distance upon the width of the road divided by the speed with which the pedestrians are moving. In this similar fashion, when it is red at B, that is the vehicles are not moving in road B, the pedestrians are allowed to move in road B, and when the vehicles are moving in road B, pedestrians are not allowed to move in road B. When these pedestrians are moving, it can be divided into the walk period, that is just like green for traffic light and clearance interval. Okay. So these are the design steps for the approximation method. The video is becoming too long, right? So I won't discuss about the numerical. I'll create another lecture regarding the numerical for this method. Just go through this method once, right? Note down everything. Go through this method once. Try to draw these phase diagram by yourself and deduce these formulas by yourself. Once you do that, the method will be clear to you. If you have any doubt, you can always ask in the comment section. All right. So I hope like this method was clear to you. Actually, the theoretical concept, the basic concepts are clear to you. If you have any doubt, you can always ask in the comment section. And if you found this video useful, like the video, subscribe to the channel. It's very important you like subscribe to the channel. Especially if you are a continuous viewer of this channel. If you find this video in this channel useful to you, do consider subscribing to the channel. Okay. Thank you for watching. Have a nice day.